Welcome everyone to another video. In today's exercise, we'll be doing exercise 2A. We have finally moved on to unit 2, which is titled, I think, just representing relationships with functions. And this unit gets a bit easier than our last one, thank God. So we'll start with 1A. 1 asks us to determine which of the following relationships are functions. For those that are functions, state the domain and range. For those that are not functions, state the reason why. Okay. Remember definition of a function. Whenever 1x can only be mapped out to 1y, so that means if we have 1, the y value for that can only be 2. It can't be 2 and negative 2, something weird like that. So 1 gives us this little shenanigan, and these are all just points from the function. We don't know what the function is, but we do know they are points. And looking at this, looks like this is a function because each x has its own unique y. So yes, and its domain is going to be the lowest x value to the highest x value, which is 1. And I guess there's several ways you can write this. I'm gonna write it like this: less than or greater than equal to x, less than, oh wait, no, actually, well, yeah, I guess you can write it like this, and then you just gotta say that x is an element of a natural number, or you can just say integer. It's positive. I guess you could also literally just write it. Range is gonna be y, so lowest y to highest y. I guess you could also write it like this, where you just put what numbers it gives. 2b, we have -2, 1, -1, 1, 0, 1, and 1, 1. Okay. Don't be tricked here. We do have multiple x's that give the same y value. As you can see, -2 gives 1, -1 gives 1, 0 gives 1, 1 gives 1. So I can already tell this is going to be like a y equals 3 or y equals 1 equation. But that doesn't mean it's not a function. Each of these x's only correspond to one value. They don't correspond to like 1, 2, 3, 4. They just correspond to 1. So it is a function. And our domain, we'll just write it how we did with our range on the last one. It'll be -2, -1, 0, and 1. And our range is just going to be 1, which is our y value. And I'd put 2b there. I did not mean to do that. Okay, 1c. We now have 2, -2, 2, -1. And look at that, I already see an issue going on here. But I'll continue to just write out what we have. 2, 0, 2, 1. Okay, this is not going to be a function. The value 2, or the value when x is equal to 2 gives us 4 different values. So we can just write down, because x equal 2 gives several values. Okay, on to 1d. We have pi, 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 -pi, pi cubed. Okay, so far no issues. And pi, is that pi to the pi? Yeah, it is. Pi to the pi, and we already have an issue here. Pi gives us pi, so that means that pi can't also give us pi to the power of pi. So no, x equals pi gives 2 values. Okay, on to d, or on to 2. Oh wait, no, there's an e too. I almost missed that. Okay, e gives us 2 little circles and then says corresponds to what? Here a is going to be equal to our x values while b is equal to our y values. So we have 1, 2, then we have 2, 4, we have 3, I think that's 10, 4, 10, and 5, 10. Okay, no issues here. That's 5 is not equal to 10, it's equal to, what was that? 2. Okay. No issues here. Each x value gives their own, well, each x value only has one y value, even though these two are the same. Remember, two different x values can equal the same equation, so that means, or the same y value, that means our domain's going to be from 1, 2, 3, 4, 5, which is our x values, and our range is going to be our lowest y value, which is 2, 4, and 10. That's our answer. Okay, on to 2. No, jeez. Okay, exercise 1 is long. I didn't realize how long it was. Okay, 1F. We're actually given a x and y table here, so let's go ahead and just map out the coordinates for all of these. We first have 4, negative 3, then x is equal to negative 5, and 1. Then we have 11, 1. Then we're given negative 5 again, but our y value is 0. So we can already tell this is not a function due to that. So no, it's not a function. And the reason is, as we said, one x value gives two y values. 1g, we're given 2, negative 5. We skip over 5, and we're just given negative 3. Negative 3, 12. Okay. The issue here is, at first it looks like a function when we just graph these 2 points. But the issue is, there's a 5 here. However, 5 doesn't get mapped to any of the numbers it gives us. It's just there. And this means it's not going to be a function. The reason is because the function does not include all domain. That is our reasoning for that. Okay, on to the last one for 1H. It gives us negative 5, 0, 2, 8. But look at that, there's 2 arrows on the 8 saying that x equals 2 gives both 18 and 15. And as we know, that means it's not a function, so the answer is no. On to 2a. Determine which of the following graphs represent functions. For those that are functions, state the domain and range. For those that do not represent functions, give a reason why. Okay, I'll do my best to draw these graphs on here. Our first graph gets us x equals 1. And this is not a function. Remember, the way we can actually test whether something is a function or not is by doing the vertical line test. We draw a vertical line, and if it passes through 2 points, it is not a function. X equals 1 is a vertical line itself, so this just fails everywhere. 2b. We have the graph of y equals 2. And this is a function. It passes the vertical line test. And now we need to state its domain and range. Domain is just going to be equal from negative infinity to positive infinity, which is just all real numbers, and its range is only going to be 2. Bracket. Okay, on to 2c. You notice how easy this one is now? I'm telling you, Unit 1 was crazy. Just wait till we get to related rates, though. That's gonna be even worse. I don't want to think about that, actually. Alright, next it gives us this little thing. This looks like an absolute value function that was flipped 270 degrees. But this does not pass the vertical line test, so it is not a function. 2D is next. 2D gives us this little wobbly thing where we have our first point as 4. Then it goes boing up, then there, and this stops at 6. Okay, that should stop at the same place, so just say that's 4. 4. And looks like this is 7. And this stops like halfway here, so I'm pretty sure that's 1. And this does pass the vertical line test, so it is a function, and its domain is going to be its lowest x value to its highest x value. So we can mark that as 1 going to be less than, wait, is it 1? Yeah, it is, because this point right here is 2, and this is, I'm pretty sure I should have said that's 1. So 1 is going to be less than or greater than, yeah, less than or equal to x, which is going to be less than or equal to 6. And for our range, our lowest point is 1 once again, which is going to be less than or equal to y, which is going to be, I did this wrong. That's supposed to be like that. Okay. Which is going to be less than or equal to 7. That's our answer for 2D. On to 2E. Okay, 2E is hell, as in it gives me like 50 different points here. And I'll try to mark them to my best. So first we have -4, 2, -1, -3. Okay, so our first point's actually going to be on 2, 0. Okay, let's start. And then we have a point all the way up on 4, 4. Then 3, 2. And 1, 1. What else do we have? We have 1 on -1, -1. So right here. Then we have 1 on -2, 2, -3. That's -2 and -4, -3. Okay. This does pass the vertical line test. So yes, this is a function. Domain is going to be its lowest. Actually, we can't even mark it like that. We're just going to have to put the numbers here for this one since it skips around a couple of x's. So it's going to be -4, -3, -2. Yeah, it skips 0. -1, and then skipping 0, 1, 2, 3, 4. And its range is going to be the same. Our lowest point is -3, -3, and then -2, -1. This one does actually include 0 because we have a 2, 0 right here. 0, 1, 2, and it skips over 3, so 4. That is our answer. Okay, 2F. We're given this little thing. This kind of looks like something you would see in physics. Three. This is going to be 1. This is going to be -2. And this is going to be -4. This passes the vertical line test, so it is a function. The domain is going to be, we'll mark it as x is an element of all real numbers such that it is less than or equal to -4 greater than or equal to -4 or less than equal to 3. And we'll do the same for our range. I'm just showing different ways you can notate domains and ranges, by the way. Our lowest value was -2. It's going to be greater than or equal to or less than or equal to x, which is less than or equal to 1. Okay, on to our last problem, 2G. Okay, this one is a bit different from the other ones, not just because it's this like swirly circle, but it actually includes arrows. That is important. Super important. So yes, this is a domain because it passes the vertical line test, but unlike our other ones, we know that these arrows means that it just goes on infinitely. So it's going to keep on going and going. So that means our domain is going to be from -infinity to infinity, which can also just be written as all real numbers. And same with our range. It's just going to keep on going to -infinity to infinity, which is just equal to all real numbers. And that is it for the exercise today. I hope you all enjoyed the video, and I'll see you all in exercise 2B.